A linear inequality looks like the equation for a line, but it has an inequality symbol like less than, greater than, less than or equal to, greater than or equal to. First thing we need to do is check whether ordered pairs are solutions to the linear inequality. To check whether it's a solution, you plug in the x value, plug in the y value, and then see if you are left with a true statement or a not true statement. So remember that ordered pairs are x and then y. So 0 is our x, 1 is our y. We would plug that in. 2 times 0 plus 3 times 1. And we're checking to see if that's greater than or equal to 5. So we are plugging our x and y value into this inequality. So we have 0 plus 3, which is 3. Is 3 greater than or equal to 5? No. So this point is not a solution to the inequality. On your own, check B and C. Plug in the x value, plug in the y value, see if it's a true statement or a false statement. For the ordered pair in B, I end up with the statement 5 is greater than or equal to 5. Is 5 greater than or equal to 5? Yes. So this point is a solution to the inequality. And the next one, 7 is greater than or equal to 5. So this point is a solution. The graph of a linear inequality shows all of the possible solutions. Anything that is shaded is a solution. You could pick one of those ordered pairs, plug it in, it would create a true statement. So let's graph some inequalities. We'll start by reviewing Vux and Hoy. This first one is Hoy, so I would write next to this one, Hoy. To remind yourself that when there's y with no x, it is a horizontal line. So this is a horizontal line. Before we draw in the line, we need to think about if this line needs to be a solid line or a dashed line. And we decide by looking at the inequality symbol. If it's a plain greater than, it's a dashed line. If it's a greater than or equal to, it's going to be a solid line. So this one's going to be solid because of the equal to portion of that symbol. So horizontal solid line at 2. Please don't be lazy. Put arrowheads on the ends of your lines, indicating that those lines are going to continue in both directions. And then the third thing we need to think about is the shading. Every teacher has their own set of tricks for this. I like to go back to what the symbols truly mean. Y is the values that we're trying to shade. We want the shaded values to be larger than or equal to 2. So if I put my pen right here on the y-axis at 2, where are the y values larger than here? Up, 3, 4, 5. So we want to shade up. And if you are a highlighter or colored pencil or crayon type of a person, you're going to love this because that's a whole lot easier way to shade. I don't care how neat or messy you are. Well, I mean, I do care somewhat. Don't be super crazy messy with your shading. I have to at least be able to see where your shading exists. But you don't have to like get it super, super perfect. Okay. I will do this a couple times as we look at linear inequalities. I'm going to put 3 points on here. You do not have to put the same 3 points on yours. You don't even have to put any of them on. I just want you to think about this in relation to what we did in the previous example. Is point A a solution to the inequality? Why is it a solution to the inequality? It's in the shaded region. It has a y value of 5. 5 is bigger than 2, so it satisfies the inequality. Is point B a solution to the inequality?
Yes.
Yes, why? It's on a solid line. Solid lines are part of the shading. Dashed lines indicate that it's like a boundary between where it's shaded and where it's not. Solid lines are shaded. Is point C a solution to the inequality? No. All right, next up we have Vux. I want blue. So first thing we need to note is that it is a vertical line. The second thing we need to think about, should this line be solid or dashed? Dashed because it is plain less than. There's no equal to line, so that's not a solid line. And then we'll have to talk about the shading once we get the line drawn. So a vertical line at -1, a dashed vertical line at -1. Even though it's dashed, don't be lazy. Get arrowheads on the ends. X's this time our shaded stuff. Our shaded stuff needs to be smaller than -1. So right on this line, it's -1. Where are the X values smaller than -1? To the left. So over here. Oops. Yeah. Okay. Really quickly, is point A a solution? Yes. Is point B a solution? No. Point B is not a solution because it is on a dashed line. The dashed is not included in the shading. Okay. We could technically graph this next one using standard form graphing. We could cover up the y and figure out that the x-intercept is 2, cover up the x, figure out that the y-intercept is 4, connect the dots. But for shading, it's really easier if we get it to look like y equals mx plus b. So if we wanted to rearrange this inequality so it looked like y equals mx plus b, what would we do first? Subtract 4x. So we would have 2y is greater than or equal to -4x plus 8. What would we do next? Divide everything by 2. So we've got y is greater than or equal to -2x plus 4. That is the inequality that we are going to graph. Start at a y value of 4, so 4 on the y-axis. Our slope is -2. That means down 2, right 1. Down 2 uses the negative, right 1. Down 2, right 1. I like to cover the graph with the dots. That way it's easier to draw my line in. If you are using a straight edge to draw this in, just extend it over the whole graph. It makes it easier to shade if you don't have a tiny little mini line drawn. Okay, so we got the line dotted in. Do we need to have a solid or a dashed line? Solid line. So draw in a solid line. Don't forget arrowheads on the ends. And cover the graph. Make sure it goes across the whole graph. For shading, I want you to think of it as y is greater than or equal to the line. -2x plus 4 is what we used to graph that line. Our y values need to be bigger than where the line is. So I typically put my pencil on the y-intercept. Our y-intercept is at 4. Right here, where are the y values bigger than 4? Up. We got 4, 5, 6, 7. That would be up this way. That's the side of the line that you need to shade. So don't think of it as like right or left or up or down. Think of it as where are the y values bigger than they are on the line. As you're graphing lines, they get steeper and steeper. figuring out where to shade can be difficult. So if you stick to the process of what's my y value here, I need y values that are bigger, where are those y values bigger? You can even put a couple dots where the y values are bigger and then shade wherever those dots are. Number 4, first thing that we need to do is rearrange the equation. So we'd start by subtracting 3x. When you subtract 3x, what's left on the left side? Negative y is less than negative 3x plus 3. Don't lose that negative. How do we get rid of the negative in front of the y? Divide by negative 1. And when we divide by a negative, your sign has to flip. So y is greater than positive 3x minus 3. Take a moment and see if you can get y is greater than negative 3x minus 3 graphed. If you at least get the dots down, then we can talk about solid, dashed, and where to shade. Should this one be solid or dashed? Dashed. So draw in a dashed line. Cover the graph. Don't forget your arrowheads on the ends. It might seem like a silly thing, but it is technically important. Greater than. This is another greater than. Put your pencil anywhere on the line. I really like the y-intercept because it just is easy. This y-intercept is at negative 3. Where are the y values bigger than negative 3? Up. Negative 2, negative 1, 0, 1, 2. That's the side of the line where you put those dots that you need to shade. So over here. You have $200 to spend on CDs and music videos. We're going to ignore the fact that this problem is completely like 20 years out of date, but whatever. CDs cost $10 each, music videos cost $20. I am going to have my x-axis be CDs and my y-axis be music videos. Okay, so CDs, those are my x's, music videos, those are my y's. So if CDs cost $10 each, we could say $10 times the number of CDs that you buy. Music videos are $20 times the number of music videos that you buy. If you add those prices up, we have $200 to spend. So this is what we are spending, and 200 is our limit. Can the amount that we spend be more than 200? No. Can the amount that we spend be less than 200? It can also be equal to 200. Now, you could rearrange this, but this particular case is one where using intercepts to graph would actually be easier. So, since we can't buy negative numbers of CDs or music videos, I'm going to make the origin of our graph be on the lower left corner of this particular graph. If I buy no CDs, so if x is 0 and I'm not buying any CDs at all, cover up 10x, you would have 20y and 200. And just imagine that it's equals for now. What would y be? 200 divided by 20 is 10. Okay. Now let's do it the other way. If I buy only CDs and no music videos, so this time the 20, that'd be the 0, we'd have 10x equals 200. So x is 20. These are our x and y intercepts. So take a moment, we need to graph our x and our y intercepts. My x-intercept is 20, and I don't think that I have 20 spaces here, so I'm going to count by 2s. 6, 8, 10, 12, 14, 16, 18, 20. I'm running out of space. Oh no.